Lesson 14.5 is more with permutations and combinations. In this section, we're going to combine what we know about permutations and combinations with some of the rules of probability involving and or. So first, we're going to combine or put together combinations and permutations using the word or. And you may remember from our basic rules of probability from earlier in the chapter that when you see or tells us that we need to add. So we're going to find 2 or 3 different individual combinations or permutations and then add the results together. In example number 1, it says a soccer team has 18 players. In how many ways can the coach randomly select 2 or 3 players to be co-captains for the next game? Notice the word or in this problem. We know that when the coach is selecting co-captains, because they're equal rank, it doesn't matter who's selected first or second. So we would use a combination to solve this problem. With 18 players on the team, 18 combination 2 would tell us the number of ways the coach could select 2 co-captains. 18 combination 3 would tell us the number of ways the coach could select 3 co-captains. So the number of ways to select 2 or 3 co-captains would be the sum of those numbers. Example number 2, there are 45 members of the football team. In how many ways can the coach randomly pick 4, 5, or 6 players to be drug tested? Again, with drug testing, like we've seen earlier in the chapter, the order is not important. So this would again be a combination situation. And this time we're going to calculate 3 different combinations because we see the word or in that problem. So 45 combination 4 would tell us the number of ways to pick 4 players. 45 combination 5 would give us the number of ways to pick 5 players. 45 combination 6 would be the number of ways to pick 6 players. So the number of ways to pick 4, 5, or 6 players would be the sum of those, which is 9,515,814 different ways. Now, when you're putting together combinations or permutations using the word and, just like in probability, refers to the operation of multiplication. So we're going to find each individual combination or permutation and then multiply the results together. In example 3, we have a basketball team with 14 players. 6 are guards and 8 are forwards or centers. If the coach wants to pick 5 players for the starting lineup by picking names from a hat, how many possible groups of 5 starters are there? Here we're assuming that the coach is going to pick 5 players from the total group of 14 without any regards to the position that they would play. So this would be a combination of 14 choose 5, which would be 2,002 different ways. Now in letter B, it says, how many ways are there for the coach to pick an ideal starting lineup of 2 guards and 3 forwards or centers? This is a little more realistic situation where maybe the coach would separate the 2 groups of players according to position and then make one choice from each group and then combine them at the end. So first, and again, notice the word and there. So first, the coach would pick 2 guards from the 6 that are available. It tells us back in the problem that 6 of the players are guards. The coach would also have to pick 3 centers from 8 available. So he's going to do both of those. So to pick 2 guards from 6 available would be 6 combination 2. To pick 3 centers from 8 available would be 8 combination 3. And then because he's going to do both of those, you would want to multiply those together. So 15 times 56 would give us the total number of ways this time. Example 4, a baseball team has 15 players. And of these 15, 6 are outfielders. The coach is going to pull 9 players' names from a hat to play in the next game. Similarly to what we saw in example 3, in part A, the first one is the coach picking 9 from the total 15 players without paying attention to what position they play. So if he's going to choose 9 from the 15 players to play in the next game, 15 combination 9 would be 5,005 ways to do that. Now this time it says in part B, how many ways are there to choose 3 outfielders from the 9 selected? And now this is assuming that he's going to make a full lineup of 9 players, but we're just looking for the number of ways that 3 of those could be outfielders. Well, 6 of the players on the team are outfielders altogether. So the coach needs to pick 3 outfielders from the 6 that are available. Picking those 3 outfielders doesn't give him a full lineup, however. So he still needs to pick 6 other players to join those 3 outfielders. And there are 9 other players that are left. So he's going to pick 3 outfielders from 6 available and then pick 6 from the other players on the team that are not outfielders. So 6 combination 3, 9 combination 6. And then even though it doesn't say it in the problem, it's implied that he's going to do both of those. So pick 3 outfielders and 6 others. So we would multiply to get the total answer. In example 5, it says a football team has 25 offensive players and 20 defensive players. The coach is going to pick 11 from each group as his starters for Friday night's game. In how many ways can he do this? So here the coach wants to pick 11 offensive players and 11 defensive players. Again, with starters, it doesn't matter what order you're chosen, you're still going to start. So this would be a combination again. So he's going to pick 11 from the 25 offensive players, 25 combination 11. He's going to pick 11 from the 20 defensive players, which would be 20 combination 11. Now, the product of this is a really large number, and your calculator may be showing you this in scientific notation, and you can leave your answer in that form. So 7.486 times 10 to the 11th power. Please do assignment 14.5 from your assignment packet.